Describe Oracle's extended data integrity activities.
For every Oracle customer running databases in a production environment, making sure that the data is reliable is very, very important. And there's a number of things that can happen. One is system crashes. We are very good at recovering from system crashes. The machine reboots, we replay the log files, we're fully back up and running in a matter of a few seconds. When there are I/O errors, a disk fails, but you have a RAID array, and the storage array comes back with an error, we can easily recover from these errors. What is the biggest problem is actual corruptions, silent corruptions that happen because an Oracle data block that's, for instance, 8 kilobyte in size got corrupted either by the kernel or something that happened all the way down to the disk. And this can occur a year after the actual corruption happened. And recovering from these situations is very difficult. They're very time consuming because we have to go back to backups. You have to make sure you have these backups. And so the downtime for silent data corruptions can be very high. Now with the data integrity project, what we are doing is basically eliminating this from happening by making sure that the Oracle data block is checksummed. It goes down to the kernel. The checksum basically follows it to the storage adapter. Then it goes all the way to the disk arrays and the actual disks. And so if a corruption happens, we get an I/O error back. We easily recover from it. But we will not write the corruption on disk, and as such never have these silent long-term issues that we have to face today.
What is the Emulex and Oracle Data Integrity Project?
In the current work that we've been doing together as partners, there's a number of phases. Of course, one is that we've worked with Emulex to make sure that the standards are there, and Emulex has been very good at driving the standards parts in the T10 organization. The companies have worked very closely together on defining the different protocols and the requirements for being able to implement this both in the operating system, the storage adapter, and the actual disks at the back end. Then there's the development efforts, and so what we have done is basically split up the work in the sense that Martin Peterson, in particular in my group, has been driving the Linux kernel development efforts. So he's been implementing the Linux OS feature requirements for supporting T10 diff, or the new name in the Linux kernel. And on the Emulex side, the people have worked hard on making sure the firmware is capable of supporting these things. And so the two have really worked hand in hand together to make sure that there's an actual solution. There have been, almost daily conference calls, or there's been a very close partnership in getting this thing done in a very short period of time. And the cooperation has just been very, very, very good.